Okay, we're going to pick up where we left off yesterday. We started talking about sine and cosine graphs. So if you guys can turn to page 4. So yesterday we discovered that using unit circle, if we just look at the values for sine at these particular quadrant values, we can have an idea how the graph is going to increase, decrease, and also the shape of the graph. So we talked about yesterday how really we just want to target the most important points. And we talked about how the values that we care most about are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we discovered that the sine graph kind of starts at rest, in this case is 0. It rises to the max value of 1, goes back down to 0, goes all the way down to -1, and then back to 0. Okay. The cosine graph is going to start at the maximum height, which in this case is 1, goes to 0, down to -1, back up to 0, and back up to 1. So sine and cosine has a full cycle of 2 pi, and it's going to start and end at the same y value. Okay. So we also talked about how amplitude is the distance from the center to the max height. And it's basically the a value. Now, there is an a value for our parent function. There's a hidden number of 1, and that is our a value for a parent graph sine theta. So a is equal to 1, and that's consistent with this graph because the distance from the center, I highlighted the center with dotted line here. Distance from the center to the maximum height is 1. So that matches with what we see here with amplitude. And then our maximum height here is also 1. And that's consistent with what we see here as well. So a equals 1. Okay. So we're going to be starting with these values for all of our sine and cosine graphs. And as we are going to talk about stretching and moving our graphs around, we're always going to use these as our kind of our anchor points. Okay? We're going to be building off of these points. Okay. All right, so let's go down to the bottom of the page. And let's talk about y equals 1/2 sine of theta. Okay. Now, what's the a value here? 1/2. Okay, it's always going to be the coefficient in front of the trig function. A equals 1/2. Now, I didn't talk about this here before, but amplitude, the formula for amplitude is actually this. It's actually the absolute value of a. So if the a value is already positive, then there's no adjustment that needs to be made. In this case, a is positive 1/2, so our amplitude is also 1/2. So really, the only thing that's going to happen with this a equals 1/2 is that the height of our graph is not going to be as high or as low. So that tells us if a is 1/2, that means the max distance from our center to the maximum height will only be 1/2 instead of 1. So really, that's really what we're going to experience as we sketch our graph. Now, we're just going to copy down our theta and sine theta from the top of the page. Okay? Just kind of getting used to the subintervals. Basically, we're just creating these order pairs from our quadrant values. So again, sine theta starts at 0. It rises to the maximum height, goes back down to 0, goes down to the minimum height, and back up to 0. So we're going to use this as our parent function value. And now all we're going to do to adjust for the fact that we have a new a value is we're going to multiply 1/2 with all these y values from our original parent graph. So 1/2 times 0 is still 0. 1/2 times 1 is 1/2. So that just allows for this change to be made. Instead of the height of 1, now our sine graph is only going to hit a max height of 1/2. Anything times 0 is 0. 1/2 times negative 1 is negative 1/2. And then 0. We're going to sketch our graph now. We're always going to be focusing on 5 points, and we're going to count 0 as one of our points. So starting with 0, we have 1, 2, 3, 4. I'm just going to label them here.
We got the labels.
Yeah, for now. I would like for us to. It seems kind of tedious, but I think the more we write it, the more comfortable we are with all these subintervals that we're going to see. Or if you just want to do a few of them, as long as you know where they are. Oops, sorry, my bad. 2 pi. This is negative pi. Yeah, negative pi. So we start at 0, 0, and also now. We're not going to use these y values anymore. These y values are kind of a stepping stone for the real y value, but this kind of acts as an anchor for us. But right now, we have our true y values, which is with a 1/2. Okay, so we have our x values, we have our y values. We're going to ignore the sine theta values. That's just kind of like a starting point for us to build the y value that we really want. So I'm just going to make my graph a little bit lower. So I have 1 and negative 1. I'll start at 0, 0. At pi over 2, I'm going to go up to 1/2. Back to 0, down to negative 1/2. And I can basically copy the points from negative. I can match negative 2 pi with 0. I can just follow the pattern, starting with negative 2 pi, matching up with 0. Okay. Do you see that distinction between the graph, between this graph and the graph above it? It's the exact same thing. It's just that we have our heights a little bit lower than our initial parent graph because of the 1/2. The 1/2 is going to force the graph to be a little bit lower than the original one. Okay. Any questions with 1? All right. Number 2. Y equals negative 4 cosine of theta. So, what's our a value here? Negative 4. Okay. But there's an adjustment that has to be made. Amplitude is the absolute value of a, so amplitude is only what? 4. Only 4. Okay. So that also, we also need to figure out then, well, what does that negative mean? All right, because 4 is what's happening in terms of changing the amplitude, but the negative is something else. Okay, so let me talk about what that is. The negative, it's going to reflect your graph over the x-axis. Okay, so basically, it's going to take this cosine graph and it's going to flip all the parts that are above to below and all the below to go above. So imagine creating a reflection of all these graphs. Now, right now we don't have to worry about creating it from the picture. We're just going to use the table to kind of help us find all the y values. But in the end, when we look at our graph, we should see that there's that reflection in terms of the shape of the graph. Okay. So theta, same. Same interval. Now, where does cosine start? Yeah, starts at the height, the max height of our graph, well, at least initially. Okay, the negative 4 is going to do something to it, but right now we're just going to kind of have our anchor to begin with. So 1, 0 goes down to the minimum y value, then it's going to move back up to my starting point. Okay. Good so far? So all we're going to do is we're going to take our parent graph and do what with it? Multiply by negative 4, right? So that a value is going to adjust for the change and is going to force a change in the shape of our graph. And it's also the reflection of our graph. Okay, so negative 4 times 1 is negative 4. Anything times 0 is 0. Negative 4 times negative 1 is 4. And negative 4 times 1 is... Okay, subintervals. Okay, so something's a little different here, right? Normally, we know that the 4 is going to force our max height to be, 4 and negative 4. But usually, we expect cosine to be starting at the maximum height. But because of the reflection, it's now going to start at the minimum height. Okay? I'm going to highlight the values that we're going to look at. We're going to ignore the middle one. The middle one was just to help us get to those last column, that last row. So we're going to start at 0, negative 4. So we're actually going to start at the lowest point and move our way to the highest point. Okay, so negative 4, 0, negative 4, pi over 2, 0, pi 4, back to 0, and back to the lowest point. So we're going to kind of have the same pattern on the left side as well. Any questions so far? Okay, give you guys a minute to copy this down if you need to. We're going to go to the next page when you guys are done. So we talked about amplitude, where our graph, where that a value is going to cause the height of our graph to change. But now we're going to talk about the period or the cycle. We're going to be stretching the cycle of our graph, either shortening it or lengthening it, and that's going to be dependent on another variable in our trig function. Okay, so we define the period of the graph as the cycle length of a graph. Now, what did we discover as the cycle length for our parent graph for sine and for cosine? They're both what? What's the length of the cycle? 2 pi, right? So for sine of theta, we know our period is 2 pi. And then for cosine of theta, it's also 2 pi. Okay, so the reason why that's occurring is also because there is this b value that's being hidden from us. There's actually a number in front of theta. It's a what? It's a 1, right? So that 1 is the b value. Because that we don't see any of the number in front, that means it's going to stay as 2 pi. Now, as the number in front of theta changes, that is going to force a change in the length of our cycle. Okay? So, given a sine of b theta and y equals a cosine of b theta, we know what the effect of a is. The a is going to stretch the graph vertically, but that b value is going to end up causing a shift in the length of our cycle. So if you guys can put a parentheses around the b theta, that's just a reminder that it's not sine times b times theta, it's sine of b theta. So that b and theta are clearly inside the sine and cosine function. Okay, so we're going to use that b value to help determine the change to the period or the length or the cycle of our graph. Okay, so here's our formula. Our formula is the new period of our sine and cosine function is going to be 2 pi divided by b. So 2 pi is kind of a starting point for us. And then whatever that b value, that's going to change that 2 pi, either lengthening it or shortening it. Okay, so put a box around this. We're going to use this quite a bit. Okay. Likewise, we can also solve for b by rearranging the p and the b and say that b is equal to 2 pi over p. But there's no, I would say we only need to memorize this one, because if we want to solve for a different variable, we can always rearrange this equation later. So this is the more important one. So p is equal to 2 pi over b. We definitely need to have this memorized. But I think after you do this a couple of times, it won't take additional effort. You'll just know it because you've seen it enough times. Okay, now once we determine the period of the graph, we need to divide the period by 4 to determine the interval. So right now, our interval, we're comfortable with those intervals that we've seen, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. But if your period is shrinking, then your subinterval is also going to be changing as well, right? We're no longer going to be doing 0, pi over 2, pi, 3 pi over 2, 2 pi, if our period is only pi, right? Then those subintervals don't make sense anymore. So because we changed our period, we also need to change our subinterval. And the way we get to our subinterval is we say interval I is equal to p over 4. We're going to subdivide into 4 equal parts. So we say I is equal to p over 4. Sometimes it's easier to think of that 4 as a 1/4. Sometimes that makes it numerically a little bit easier to, but they mean the same thing. You can either think of it as taking your p-value, dividing it by 4, or you can think of it as 1/4 times your period value, because sometimes if you're dividing by a fraction, it can be a little uglier. So multiplying by a fraction is a little bit cleaner sometimes. So they're, just whichever one you feel more comfortable with, or you can alternate between those forms just depending on where the fractions are. All right, so let's look at some examples here. Y equals sine of 2 theta. So this is no longer y equals sine of theta. That 2 is going to impact the length of our cycle. No longer going to be 2 pi. So let's put a parentheses around it as a reminder that the 2 theta is clearly inside the sine function. Okay. All right, what's our b value here? 2, right? The a is going to be outside. We don't have it. Well, the a value is 1. It's not changing. It's the b value that's changing. Okay, so now we know that b value is going to impact our period. It's no longer going to be 2 pi. It's going to make some changes to 2 pi. So we're going to go through our formula. Our new period is going to be our parent period divided by b, so 2 pi over b. So 2 pi over 2, what does that give us? Pi. So our sine graph is still going to look the same. It's still going to have the rise and fall that we've seen, but is it going to complete that cycle faster or slower? Faster, right? So now it's going to complete its full cycle within 1 pi, whereas before, it was taking 2 pi before it completed the cycle. Now, because our cycle is only pi, our interval has to change as well, right? Our interval is no longer pi over 2 pi, 3 pi over 2, 2 pi, because that doesn't make sense for our new period. So to find our new subinterval, we're going to take our new period and divide it by 4. So that's just what this is doing here, p divided by 4. So, pi over 4, well, that's just it, right? Pi over 4. So, the way that we're going to find our subinterval, we're going to keep adding pi over 4 to the previous number. And for now, we're always going to start at 0. Okay? So let's go through this process. Okay? 0 plus pi over 4 is pi over 4. Or you can think of it in terms of fraction, right? How we did before with our unit circle. So 1/4 plus 1/4 is 2/4, which is 1/2. 2/4 plus 1/4 is 3/4. And then 3/4 plus 1/4 is 4 over 4, which is pi. So you know that you're on the right track if by the time you get to your end, you have reached the length of your period. Right? If you haven't done so, that means you either added wrong with the fraction or maybe you found the wrong interval. Okay. All right, any questions there? Now the nice thing here is that our y value is going to stay exactly the same. Okay? All we need to do is just go through our y value that we've done that we've done before. So where does sine start? 0. It rises to a height of 1, goes down to 0, -1, and 0. So that's nice that our y value doesn't have to change because our a value is not changing it. Okay, so it's nice to just, if it stretches or compresses, we just have to find where the intervals are so that we have that nice y value that we can reuse over and over again. Okay, so see if you guys can graph this. Now, technically we should be stretching our graph or compressing it depending on the interval, but we can assign our interval, right? So instead of going all the way to 2 pi, we're just going to, technically we're making it compressed, where we're completing our full cycle within pi. Okay, so go ahead and fill this in. Your graph is going to look the same. It's just that we've reassigned these tick marks here. Okay, do the same thing on the other side. Okay, any questions so far? All right, so let's look at number 4. Number 4, we see that there's something done to that theta there. There's a b value. Can you identify what that b value is? Okay, so looking at that divided by 2, it looks a little bit strange because it doesn't quite look like what we had before. Now, what you can do is, if you see a fraction, maybe it helps to rewrite it into a form that's maybe more familiar. We can push that 2 out in front as a what? As a 1/2. So if you want to push a denominator out in front as 1/2, maybe that's more familiar because then you can see that b value clearly in front of theta. Okay, so we let our b value be 1/2. We know that's ultimately going to change the length of our cycle, our period. So our formula is, again, 2 pi divided by b. 2 pi divided by b. Okay, so 2 pi divided by 1/2. What does that become? 4 pi, right? Dividing by a fraction is the same thing as multiplying by the reciprocal. So 2 times 2 is 4. So now it's taking a lot longer for our cosine function to complete the cycle. But we have to also adjust the interval, right? Because we have a longer period, and we're going to have a longer subintervals as well. So how do we find out those subintervals? Take our new period and divide by what? Divide by 4, right? We're always going to be splitting up into quarters. So what's 4 pi divided by 4? Just pi. So now that you have your interval, you're going to start at 0, and you're going to keep adding pi until you reach your period length. Okay? So 0, what's next? Okay, so these are nice whole numbers, right? So we can just keep adding it. All right, what do you know about cosine? Cosine starts 1, and it just makes its way down to the lowest y value and back up. Yes? Okay. Okay. Sketch your graph. You can redefine your subintervals to be 0 through 4 pi. Okay, any questions here? Okay, does anybody still need this problem here? All right, let's look at number 5. Now we have we're going to graph sine and cosine function with changes to both the amplitude and the period. So, but let's gather information first, and then we can do one thing at a time. Okay, okay, y equals -3 sine of 4 theta. Notice that we have things changing with both the a and b value. What's our a value? -3. But the amplitude is only what? It's only 3. Good. But we know that we see that negative there. We know there's going to be some reflection going on, right? It's not going to look exactly like what we expect from the sine graph. Everything's going to be kind of flipped. Yes. Yeah. Can you wait until Susan comes back? Okay, what's our b value? B value is just the 4, right? Okay. We know that that 4 is going to change the length of our period, so how do we figure out that change there? What's our formula? 2 pi divided by 4. Good. So we're taking our initial period length and dividing by 4 to get our new. Okay, so 2 pi divided by 4, which reduces to be pi over 2. Good. So it's going to have to get through its entire cycle in a short amount of time, just within pi over 2. And also we want to make our interval reflect that change in period. So how do we find our new subinterval length? Yeah, divided by 4, right? So pi over 2 divided by 4. Now pi over 2 divided by 4, you can think of it as divided by 4, or you can do it as 1/4 times pi over 2. Either way, we'll get the same answer. So if you did pi over 2 divided by 4, you can think of it as dividing by 4, same thing as multiplying by 1/4. So we get pi over 2 times 1/4, which is pi over 8. Okay? So now we're going to be incrementing by 1/8 through our subintervals, and we should end up at pi over 2. Okay? So 0 plus 1/8 is 1/8. Plus 1/8 is, yep, 2/8, which is 1/4. 2/8 plus 1/8 is 3/8. 3/8 plus 1/8 is, yep, 1/2 pi over 2. Okay? We know that there's going to be something with the a value, but let's just go ahead and kind of anchor our y values. It kind of gives us a starting point. What do you know about the sine graph? Sine graph starts at 0, and it's going to make its rise up to its max, back down to 0, all the way down to the minimum, and back to the original place. Okay, these are not the y values we're going to graph, but it's nice to have these y values here because we can just multiply with our new a value, and kind of gives us a starting point. Okay, so now we just take our parent y values and multiply it by our new a value. Anything times 0 is 0. Okay, sketch your graph. And we're going to see something a little strange with the sine graph. It's going to be kind of flipped because of the reflection, right? We're going to see that our sine graph, instead of rising, it's going to start its path down towards its minimum first because of the negative, because of the reflection. Okay, how do you guys feel about the steps? So, when you guys try number 6, when you go through the same process that we did as number 5, you identify your a value, identify your b value, decide what adjustment do we need to do to find our new period. Once you find a new period, adjust that period so that you can break it into the correct subinterval. Build your original y values from your cosine, and then you can use that to help you find your new y values depending on the amplitude of our problem. sketch your graph like before. Okay, come around and see if you guys need any help. Divided by a fraction is taking the whole number. Now, we have a much lengthier area.
I can tell. It's not diagonal.
Yeah, we're going to make our own table. Okay, let's go over number 6. Do you guys have any questions? So our A value is 2. That B value, if you're uncomfortable seeing that 3 in the denominator, push that out as 1/3. And that's our B value. B is 1/3. Okay. So our period is 2 pi divided by b. So 2 pi divided by 1/3, that's the same thing as 2 pi multiplied by the reciprocal. So 2 times 3 is 6. 6 pi is our new period. It's a lot lengthier than our previous parent period. But we have to get this into its correct subinterval, so we always divide our full period by 4. So 6 divided by 4 is 3/2, which is 1.5. So then we always start at 0, and we're going to keep adding our subinterval by 3/2. And by the time we reach our end, we should match the length of our full period. Okay. Our cosine starts at 1, makes its way down, then back up. This is not the y value you're going to graph, but this is helpful because now I can just multiply those y values by my new amplitude. Okay. So once I have all those values, I'm just going to graph it onto my coordinate plane. Okay, any questions here? Okay, let's go to the next page. Okay, so here we're just basically going to do the same thing as before, just that we're going to, kind of see if we can make our own chart and graph. So for each function, state the amplitude and period, then label the axis appropriately and sketch the graph. Now, what's the amplitude for number 1 here? Just 5, okay? So that's the a value, right? What's the b value for this function? Just 1. So that means my period is not going to change, or you think of it as 2 pi divided by b, 2 pi divided by 1. It's not going to change. So the period is going to be 2 pi. Okay. Is there any difference in any of these periods between 1 through 4? No. Okay, so that's nice. These are all going to be easy intervals because we're just going to be using our parent graph. The only thing that's going to change is the amplitude. So I'm going to just create a chart here. Theta is just going to be my original subintervals. Basically, my quadrant values on my unit circle. I'm going to start off with cosine theta. I know cosine is going to start at 1. And now I'll bring in the 5. Okay, multiply everything by 5. It's only going to affect the 1 and -1. The zeros will stay 0. Okay, and then just sketch our graph. Okay, cosine starts at the max, makes its way down to the min, then back up to the max. Okay, same thing as before, we're just kind of creating our own chart, kind of getting used to making our own chart and making our own graph. Okay, see if you guys can finish 2 through 4. You don't have to do the chart. I think that the chart is helpful just to map out everything, but if you're comfortable with the values, then you don't have to do that. Okay, what's different about number 3 and number 4? This is going to be reflection, right? So that's the negative, we got to bring that negative in. Going to change the shape of this cosine and sine graph a little bit. And again, the middle line is just there to help you get to that last line. You're not going to graph that middle line. You're just going to pay attention to your theta and then your last line. That middle line is helpful, though. It just kind of gives us a starting point to build our amplitude. And I'd like for you guys to practice graphing on the negative side as well as the positive side. So instead of stretching up to 1 and negative 1, it's only going to go up to 5. So this graph is going to start at the lowest point and move up. That negative is going to force them. Now, the cycle should end at the same point. So let's start the negative 1/3 and you can end it with that.
We're the person who lost the new driver. Never mind, never mind.
Okay, your homework is just to finish this page. Most of you guys did, so I'll check this off. Good.
Not that that's ever stopped at school. I think about the number of times everyone.